Hi, this is Mrs. LaBarbara. Today I want to talk about question 1 of 1981 AP Mechanics exam. A block of mass m acted on by a force of magnitude F directed horizontally to the right as shown, slides up an inclined plane that makes an angle theta with horizontal. The coefficient of sliding friction between the block and the plane is mu. First question is to draw and label all the forces that act on the block as it slides up the plane. So here is a block. What are the forces acting on this block? First, we know there's definitely gravitational force, which is always downward. There is also normal force. This normal force is perpendicular to the plane. Normal means perpendicular in math. Next one, you'll have applied force F. Besides this force, there is also friction force that's toward down the plane. Friction force is always opposite of motion. Since the block is moving up the plane, so friction force is opposite of that up. That's why it's down the plane. Next question, you are asked to develop an expression in terms of m theta, f, mu, and g for the block's acceleration up the plane. In order to find the acceleration up the plane, we have to find the net force. But before we even do that, we need to give it coordinate. Since it's moving up the incline, so I've decided to have coordinate up the incline as positive x, and perpendicular incline that gives y, positive y, is the one upward. So in order to find force, we need to separate x direction and y direction in the force. Let's consider all the forces. First is force F. This is F, and this we have to separate that into x and y components. As you can see, theta is between F and x, therefore Fx becomes F cosine theta and Fy is negative F sine theta. It's negative because it's opposite of positive y. Next force is gravity. As you can see, the theta between gravity and the negative y, that's the theta. So as a result, we have mg, x would be negative mg sine theta because that is the side opposite of this theta. Mgy becomes negative mg cosine theta. Again, it's negative, is opposite of up, it's going downward. So after we resolve it, we can get rid of this mg just as we got rid of f. The other force is this friction force. This friction force only has x component, which is negative mu times Fn. Fn is just n. It has no y component. Last force is normal force. This normal force only has a y component and has no x component. So we know the block is only moving in the x direction. In the y direction, the force is 0. So the net force in the x direction gives us m times ax according to Newton's second law. All the force in the y direction added together equals 0. So when you add all the force in x direction, we have f cosine theta minus mg sine theta minus mu times n should be equals to m times ax. The problem over here is we know f, we know theta, we know m and g, but we don't know n. So in order to find n, we have to look at y direction. Since all the force in the y direction equals 0, so we can solve n in this case. Negative f sine theta minus mg cosine theta plus n equals 0. We solve n equals f sine theta plus mg cosine theta. From here, since we know n, we can substitute n in the fx direction, f cosine theta minus mg sine theta minus mu times n. N equals f sine theta plus mg cosine theta equals m times ax. To solve ax, we simply Divide both sides by m. Last question. Develop an expression for the magnitude of force F that will allow the block to slide on the plane with constant velocity. That's part 1. So for it to have constant velocity, AX has to be 0. That means whole expression has to be 0. So the top has to be 0. That means F cosine theta minus mg sine theta minus mu F sine theta plus mg cosine theta equals 0. We simply combine the terms as F and solve for F. So F equals mg sine theta plus mu cosine theta divided by the cosine theta minus mu sine theta. I got this because I factoring F out, so cosine theta, this term would become mu times sine theta, and this both are negative. Move to the other side of the equation, you'll have a plus sign. Next question says, what relation must theta and mu satisfy in order for this solution to be physically meaningful? What does that mean, physically meaningful? Physically meaningful means F has to be greater than 0, right? For the solution to be physically meaningful means F has to be greater than 0. If this has to be greater than 0, that means denominator has to be positive. Cosine theta has to be bigger than mu sine theta. This gives us mu has to be less than cotangent theta. And that is the answer for theta, the relationship between theta and mu. So this relationship has to be satisfied in order to be the solution, this F, to be meaningful. That's it. Thanks for watching.